National Electrical Code Section 300.22 addresses wiring methods and materials located in plenum chambers. Section 110.3b generally covers locations not permitted by code. Section 409.1 applies to enclosed electrical equipment. Section 430.14 focuses on dry-type transformers. Section 450.47 covers switchboards and panel boards. Section 490.42 relates to isolating switches. Section 501.10 pertains to fire stopping. Section 530.13 applies to busways. International Building Code Section 425.2 gives a definition of plenum. Section 510 covers electrical fire prevention. Section 712.1 is for air plenum systems. Underwriters Laboratories UL 2043 relates to fire resistance ratings of electrical enclosures. Institute of Electrical and Electronics Engineers IEEC 37.95 addresses transformers. IEEC 37.46 covers indoor disconnects and switches. National Fire Protection Association NFPA 90 is the standard for air conditioning and ventilating systems. NFPA 13 is the standard for the installation of sprinkler systems. Additional considerations include local building codes and fire regulations, which may have additional requirements or restrictions on electrical equipment in plenums. Proper ventilation and fire suppression measures must be in place to maintain acceptable temperatures and control fire hazards. Equipment should be accessible for inspections, maintenance, and emergency operations. Electrical equipment may need to be enclosed in fire-rated cabinets or compartments to meet code requirements. It's imperative to consult these codes and standards in detail, tailoring them to the specific installation at hand. Let's delve into each of these sections a bit further to provide a more comprehensive understanding. First, National Electrical Code Section 300.22. This section is dedicated to wiring methods and materials within plenum chambers. Plenums are essentially enclosed spaces used for air handling, so the wiring here must be fire-resistant and low smoke-producing. This is because any fire or smoke could be distributed throughout the building via the ventilation system. Types of cables approved for plenum use are typically plenum-rated cables, often identified with a CMP designation. These cables are designed to limit the spread of fire and reduce smoke emissions. Next, consider National Electrical Code Section 110.3b, which generally covers the installation and use of listed or labeled equipment. This section is crucial because it mandates that electrical equipment must be installed and used in accordance with any instructions included in the listing or labeling. If the equipment is not suitable for a plenum environment, it should not be installed there. Following that, take a look at National Electrical Code Section 409.1, which discusses enclosed electrical equipment, particularly industrial control panels. If these panels are placed in a plenum, they need to be designed and constructed to prevent the spread of fire. This can mean using fire-resistant materials and proper sealing methods. Now, let's discuss National Electrical Code Section 430.14, which addresses the installation of dry-type transformers. Dry-type transformers generate heat, and in a plenum, it's essential to ensure they are adequately ventilated to prevent overheating. The code specifies clearances and ventilation requirements to ensure safe operation. In addition, National Electrical Code Section 450.47 is specifically about switchboards and panel boards. These components, when located in a plenum, must meet certain fire resistance and ventilation standards. Panel board should be enclosed in fire-rated enclosures to prevent any potential fire from spreading. Next, explore National Electrical Code Section 490.42, which covers isolating switches. These switches must be readily accessible and clearly labeled. In a plenum, accessibility is key for maintenance and emergency situations. National Electrical Code Section 501.10 is about fire stopping. Whenever electrical wiring or equipment penetrates a fire-rated barrier in a plenum, fire-stopping materials must be used to maintain the integrity of the fire barrier. This prevents fire and smoke from spreading through the openings. Consider National Electrical Code Section 530.13, which addresses busways. If busways are routed through a plenum, they must be designed and installed to prevent the spread of fire. Busways should have appropriate fire-resistant enclosures and supports. Now let's move on to the International Building Code. International Building Code Section 425.2 provides a definition of what constitutes a plenum. This definition is important because it determines whether a space is subject to specific requirements for materials and equipment. The definition often refers to spaces used for air handling in a building's ventilation system. And now International Building Code Section 510, which covers electrical fire prevention, is extremely important. It outlines measures to prevent electrical fires, including proper wiring methods, overcurrent protection, and grounding. These measures are particularly important in plenums, where a fire could spread rapidly. International Building Code Section 712.1 deals with air plenum systems. This section specifies requirements for the construction and materials used in air plenum systems to minimize fire hazards. It often references other standards such as NFPA 90A for detailed requirements. When it comes to underwriters' laboratories, consider UL 2043, which pertains to fire resistance ratings of electrical enclosures. This standard is used to evaluate the fire performance of electrical enclosures and determine their suitability for use in plenums. Enclosures that meet UL 2043 requirements are designed to contain a fire for a specified period of time. IEC 37.95 focuses on transformers. This standard provides guidelines for the design, construction, and testing of transformers to ensure their safe and reliable operation. Transformers used in plenums should meet these standards. Furthermore, IEC 37.46 covers indoor disconnects and switches. This standard provides requirements for the design, construction, and testing of disconnects and switches to ensure they can safely interrupt electrical circuits. These components must be suitable for the intended voltage and current levels. When it comes to National Fire Protection Association, NFPA 90 is the standard for air conditioning and ventilating systems. This standard provides detailed requirements for the installation and maintenance of air conditioning and ventilation systems to prevent the spread of fire and smoke. It covers topics such as duct construction, fire dampers, and smoke detectors. Additionally, NFPA 13 is the standard for the installation of sprinkler systems. Sprinkler systems are often required in plenums to provide fire suppression. This standard specifies the design, installation, and testing requirements for sprinkler systems. Now, regarding additional considerations, local building codes and fire regulations can impose extra requirements or restrictions on electrical equipment in plenums. It's essential to consult these local codes to ensure compliance. Also, proper ventilation and fire suppression measures are paramount. This includes adequate airflow to prevent overheating and fire suppression systems like sprinklers to control any potential fire. Access and maintenance are also important. Equipment in plenums should be easily accessible for inspections, maintenance, and emergency operations. This might require the use of access panels or doors. Last but not least, electrical equipment might need to be enclosed in fire-rated cabinets or compartments to meet code requirements. These enclosures are designed to contain a fire for a specified period, giving occupants time to evacuate. Therefore, ensuring compliance with these codes and standards is crucial for maintaining safety and preventing fire hazards in buildings with air plenums. Always consult with qualified electrical engineers and fire safety professionals to ensure that your installations meet all applicable requirements. Remember, the specific requirements can vary depending on the jurisdiction and the specific characteristics of the building and plenum. Therefore, thorough research and professional guidance are essential for a safe and compliant installation. When considering the installation of electrical equipment in air plenums, several key aspects warrant careful attention to ensure safety and compliance with relevant codes and standards. Firstly, material selection plays a critical role. In plenum spaces, only materials that exhibit low smoke and flame characteristics should be used. This is to mitigate the risk of toxic fumes and rapid fire spread in the event of a fire. For wiring, Plenum-rated cables typically marked with CMP are designed to meet these stringent requirements. Similarly, any other non-electrical materials, such as cable ties or supports, should also be Plenum-rated. Secondly, proper ventilation is essential for electrical equipment that generates heat, such as transformers and some lighting fixtures. Adequate ventilation prevents overheating, which can lead to equipment failure and potentially ignite a fire. The specific ventilation requirements often depend on the equipment's heat output and the ambient temperature of the plenum space. Manufacturer specifications should be consulted, and local codes may also dictate minimum ventilation standards. Thirdly, fire-stopping measures are crucial to maintain the integrity of fire-rated barriers within the plenum. Whenever electrical wiring or equipment penetrates walls or floors that are part of a fire resistance rated assembly, the openings must be sealed with approved fire-stopping materials. These materials prevent the passage of fire and smoke through the penetrations, helping to contain the spread of fire. Fourthly, accessibility for maintenance and inspection is often overlooked but is vital for the long-term safety and reliability of electrical installations in plenums. Equipment should be located and arranged in a way that allows for easy access for routine maintenance, troubleshooting, and emergency repairs. This may involve providing access panels or dedicated pathways to the equipment. Fifthly, emergency shutdown procedures should be clearly defined and readily accessible. In the event of a fire or other emergency, it's important to be able to quickly de-energize electrical equipment in the plenum to minimize the risk of electrical shock and further damage. Emergency shutdown switches should be prominently labeled and located in easily accessible areas. Sixthly, grounding and bonding are crucial for electrical safety in all installations, including those in plenums. Proper grounding and bonding help to minimize the risk of electrical shock and prevent the buildup of static electricity, which can be a fire hazard. All electrical equipment and metal components in the plenum should be properly grounded and bonded in accordance with applicable codes and standards. Seventhly, regular inspections and maintenance are essential for ensuring the continued safety and compliance of electrical installations in plenums. Regular inspections can help to identify potential problems such as damaged wiring, loose connections, or inadequate ventilation. Maintenance activities such as cleaning and tightening connections can help to prevent equipment failures and maintain optimal performance. Eighthly, consider the use of fire-rated enclosures. In some cases, it may be necessary to enclose electrical equipment in fire-rated enclosures to provide an additional layer of protection against fire. These enclosures are designed to contain a fire for a specified period, giving occupants time to evacuate and allowing firefighters to respond effectively. Ninthly, coordination with other building systems is essential for ensuring the overall safety and functionality of the plenum space. Electrical installation should be coordinated with other systems such as HVAC, fire suppression, and communication systems to avoid conflicts and ensure that all systems work together effectively. Lastly, and perhaps most importantly, always consult with qualified professionals. Designing and installing electrical systems in plenums requires specialized knowledge and expertise. It's important to work with qualified electrical engineers, contractors, and fire safety professionals to ensure that the installation meets all applicable codes and standards and is safe for building occupants. Remember, these considerations are not exhaustive, and the specific requirements for electrical installations in plenums can vary depending on the jurisdiction, building type, and occupancy. It's essential to conduct a thorough assessment of the specific conditions and consult with qualified professionals to ensure safe and compliant installation. In conclusion, navigating the complexities of electrical equipment installations in air plenums demands a comprehensive understanding of various codes, standards, and best practices. From selecting appropriate materials to implementing robust fire safety measures and ensuring accessibility for maintenance, every aspect of the installation must be carefully considered. By adhering to the guidelines outlined in the NEC, IEC, OL, IEE, and NFPA standards, and by consulting with qualified professionals, building owners and operators can create safe, reliable, and compliant electrical systems in plenum spaces, safeguarding the well-being of occupants and protecting property from fire hazards.